Morning dear students, I am Asha Pawar working as assistant professor at SNJB's Letso KBJ College of Engineering Sandwat Nasik. Student, today we learn quantum dots in engineering chemistry. So what are quantum dots? Quantum dots are semiconductor nanoparticles that glow a particular color after being illuminated by light. Means quantum dot are such a material in chemistry. It is nothing but the semiconductor characteristic, and it is a nanoparticle, that is its particle size less than 100 nanometer, and it glow particular or different types of color after illuminated by light. So there are different types of nanomaterials are there. In your syllabus there are three different types of nanomaterials are there. First is third, fifth semiconductor quantum dots. This type of quantum dots are made up of from the element, that is from the group third of the periodic table, and the element included in the group third, you know that is like boron, aluminum, indium, etc. And from group fifth, that is the element like nitrogen, phosphorus, arsenic, bismuth. And the example of this type of semiconductor quantum dots are gallium arsenic. It is used as a light source in optical data processing and in laser. Okay, means this type of semiconductor quantum dot are made up of by using the element of group third and group fifth in the periodic table. Second type of quantum dots are second, sixth semiconductor quantum dot. They are made up of element from the group second, that is transition metal of the periodic table of the element like zinc, cadmium, etc. And from the group 6 like oxygen, sulfur, selenium, tellurium. And the most common type of semiconductor from this category like zinc oxide, cadmium, tellurium, cadmium, selenium, etc. Means this type of quantum dots are made up of from the element that from group second and group sixth. And the last type of quantum dots are very commonly used in the electronic chips, that is the silicon quantum dot. They are made up of from the element silicon, which is the standard material of semiconductor and chip industry. Silicon quantum dots have a greater potential to be used as a component of optical chip and optical sensor. Means most of the most important use of silicon quantum dot, that is in the chip industry, that is in optical sensor and in optical chips. So next point is properties of quantum dots. There are different types of properties shown by the quantum dot. First one is the optical properties. It is a very important. You know that the quantum dots are semiconductor nanomaterial, and it is a very small size. If we pass light through the quantum dots material, it produce a different color light, and depending upon the product light production, it is depend upon always size. As the size increases, the color intensity also changes. That is most characteristic property, that their color is depend upon the size of the nanomaterial. And during the synthesis of quantum dot, it is one of the type of nanomaterial. Different size of nanomaterial, that is quantum dot, if we prepared and we observe the optical property, it is observed that as the size increases, the color intensity also increases. And always smaller dots emit higher energy light, and that is bluer in color, whereas bigger dot emit lower energy red color light. Means small size quantum dot always emit high energy light like a blue color, and a bigger size quantum dot emit lower energy light, a red light. Next important, that is the specific color glow of quantum dot depend upon the size of the nanoparticle. Already I told you, that is the color intensity or which type of color can be glown by the quantum dot, it depend upon its size, and which color, specific color glows of quantum dot depend upon size of nanoparticle. Observe this diagram. Here the wavelength can be shown in a nanometer, and at this upper side the size, as the size changes, quantum dot also emit a different light. See, this is a blue color, means small size nanoparticle emit a blue color, and this is a bigger nanoparticle or quantum dot emit a high wavelength light, that is a around 700 nanometer light. Means as the size changes, color intensity also changes. And the second, that is which color or specific color glows by quantum dot, also depend upon the energy difference between valence band and conduction band. Observe this diagram. In this diagram, as a size changes, means size decreases, energy gap between valence band and conduction band increases. Means smaller size quantum dot always having emit high light energy, that is valence band and conduction band difference of energy is higher. Then bigger size quantum dot always emit lower energy, that is valence band and conduction band energy gap is low, that is the band gap of quantum dot exhibit an observed before direct relationship to their size. The energy band gap is inversely proportional to the size of quantum dot. Means the higher energy smaller quantum dot, larger smaller energy bigger size quantum dot. This property of quantum dot make it possible to use them in a variety of application, that is in optical instrument and many more. And the last point in quantum dot, that is the application. Due to the very good light emitting characteristic, it is a size dependent, therefore quantum dots are always used in a various field. Quantum dot may some daylight your home, office, street. Means you, in the today's era we use QLED light emitting diode, that made up of from the quantum dots. Quantum dot LED can now produce any color of light including white also. So quantum dot LEDs are extremely energy efficient. They use only in few watts, means energy requirement is very less, that's why they use in various offices, homes, and in entire cities, malls, etc. Then in a photovoltaic devices, quantum dots may be able to increase the efficiency and reduce the cost of today's typical silicon photovoltaic cell. That's why quantum dots photovoltaic cell would be used in a various field, and using simple chemical reaction they can be made up. That's why in a photovoltaic devices quantum dots are used. Then quantum dot can also use in the solar cell. Quantum dot can also used in the field of medical, for the medical imaging. The photo shown here, it is nothing but the human red blood cells, in which specific membrane properties are targeted. See this blue color light, and labeled with a quantum dot. The number of purple features in this RBC, that is red blood cells, which indicate the nuclei of malaria parasite. That is in the medical field, for medical imaging quantum dots can also be used. Also quantum dots can use for the cell imaging. Quantum dot last longer in your system and are brighter than many organic dyes and fluorescent proteins, and that's why quantum dots can be used for the cell imaging. They can monitoring the changes in cellular processes, while most high resolution technique can be used. So the quantum dots are very useful in the various field. They can also use for the cancer cell imaging,